right, well, I think that's a good starting place. Again, good morning. Thank you so much for everybody that is coming to join us today. Welcome to the Makersite's Masterclass, Transforming Chemical Data Gaps into Sustainable Product Decisions. Over the next 45 minutes or so, we're going to go through how AI-assisted chemical data modeling can help organizations generate transparent and traceable draft chemical models when measured data simply does not exist or it's fragmented, and how that can enable some faster, more scalable decision-making. Joining us today are two people who spend a tremendous amount of time working directly at the intersection of sustainability, science, chemical modeling, and real-world implementation. First, we have Ms. Sophie, Makersite's Senior Sustainability Expert and Solutions Delivery Team Manager, and Peter, LCA Expert at Makersite. They'll be guiding us through our presentation today. Just a few quick housekeeping notes before we begin. This session is recorded, and we will be sharing the recording and the presentation with all registrations later today. And then also feel free to drop any questions in the chat or the QA throughout the session. We will hold those questions though for the end for our Q&A. So again, feel free to drop those in the chat and we'll make sure to get to all the questions. If they're a little bit more nuanced, we'll make sure to reach out to you after the presentation. And with that, I'll hand it over to Sophie and Peter and we'll get us started.
Thank you very much, Corinne. So welcome to the webinar and welcome to the class. Thank you for taking the time. So I want to start with a quick intro. I mean, Corinne already had a few nice words about us, but just quickly, my name is Sophie Kieselbach. Basically all my career have been working in LCA and sustainability and also with chemical companies a lot. And Peter, you might want to introduce yourself as well.
Yes, thank you, Sophie. I'm Peter Slorick. I work at Makersite as an LCA expert, specialising in chemicals projects. My training is as a chemical engineer, and I started out in LCA about 10 years ago now during my PhD at the University of Manchester, and went on to do academic research and then applied LCA in sustainability consultancies. So a lot of experience in working with consumer goods and pharmaceuticals and food, and have now started at Makersite, so looking to apply that rigor to a software and large data approach to LCA.
Thank you, Peter. So today we'll guide you a bit through what, as the title says, like transforming chemical data gaps into sustainable product decisions. We'll have a nice intro. We'll also have a short demo. But first, before we get to that, I just have a few words about Makersite for the ones that do not know us yet. So who are we? Makersite is a software as a service company. The headquarters in Stuttgart, and we have offices in Europe and in the US. We have been founded in 2018 by industry veterans. We have right now about 160 plus employees and have about, we are trusted by 50 plus global manufacturers, as it says here written, such as 3M or Trox or Milliken. Our mission is to empower companies to make better and faster decisions. And we do that by basically helping you creating compliant and sustainable products, and that by having data-driven analysis for each and every product that you have. How do we do that? We don't do single products, we do everything at once. So we connect to your data, we enrich those data with supply chain data, such as, for example, in LCA or PCF's background data sets. Both together, we are using some AI for it, we're using technology for it, and that together gives you models that will enable you to get more than one output. So it's not just LCA, it's not just PCF. Basically, you're with that approach, you're enabled to have every information that you need to make a product more sustainable in the sense of like more productive in regards to compliance, cost, sustainability, and supply chain risk. So that is Makersite, and as I said, we have a short agenda for today. We're talking a bit about why does it matter, the challenges of chemical manufacturers, what is ChemAI, then we'll have a short demo, and in the end we will have some time for Q&A. So let's start. Why does this matter, right? We all know that a lot of the product's environmental impact is determined during the design phase, and that phase is also determining the compliance, the costs, the affordability, the performance, and other things, right? And because of that, it is really important to get your product right. If you want to save money, if you want to make it more affordable, if you want to make it more environmental friendly, you have to start on where the product is designed. Why does this even matter, right? Besides that you can actually save money. It's also that there is a lot of requirements in the market right now and it's getting more and more complex with each month that we are in, basically. So you have very, very complex documentation requirements about your products, and they are getting more strict, for example, in Europe with all the regulations coming up. That leads to someone is having to collect the data, having suppliers questioned of their data so that you have your supply chain as well displayed. And it's usually very reactive if you do it one by one and not very proactive. But if I'm a manufacturer, I actually want to know where do I have risks regarding regulatory pressures, where do I have risks to actually lose money. And if I'm not compliant, then I'm not just not compliant. I'm also, as I said, losing market in a lot. For example, if I can't deliver a TFS compliant document to my customer, then I might just lose that customer. So it's not just about regulatory pressure, but also pressure from your suppliers or your customers. So because of that, right? People are forced to speed up and somehow automate the processes to get data in and have the information together. And if we then look at the chemical sector, we have a few challenges that come with chemical data. And we have a certain data gap problem if you're in the chemical industry. What is it? It's not just one gap, it's the data gaps are actually everywhere because data are never perfect. It starts with your suppliers. So if you get supplier information about what you're actually buying, it might be that you are not getting the full composition data. That could be because only compliance necessary ingredients are displayed. Maybe there are trade secrets which obscure the details. It might be that you only get a brand name. Basically, because so far you have been buying based on technical capabilities and not on what is in there, right? It could be, if we go further and within the company and also on supplier side, it could be that you are missing material descriptions. So one, the nomenclature for chemicals is often not maintained properly within the company, within the departments. It could be that CAS numbers are missing, UPAC is missing. It could be that that different names are actually used for the same chemical, or that it is displayed as formula or abbreviation, and then you actually are missing a lot of details, right? That's another gap. And the third gap, where we also actually are hooking in today, is the LCI data. So typically we have the background databases, as you're all aware, such as EcoInvent or Carbon Mines. But the more specific a chemical gets, the less chance you have that you actually have a background data set for that. So the data availability decreases, and with that, you have an increasing uncertainty. So the more specific chemicals you're using in your recipes during manufacturing, the more uncertainty you have in the final results, because basically there are some data sets that everyone is then mapping to, or in worst case, people are leaving it and you have a gap in the result. Yeah. So what does that mean? Peter, handing over to you.
Yes, thank you, Sophie. So the traditional approach to this, which I'm sure many of people on this webinar are aware of as LCA practitioners, is very manual. So we're looking at cleaning up data. So we need to look at all these chemicals which are listed. We need to clean them up. We need to give them consistent names and maybe look up CAS numbers. And then once we've done that, we'll find that the coverage within these existing data sets is limited, as Sophie says. So there's only well-documented chemicals in eco-invent and carbon mines, and they're both incredibly useful for LCA and invaluable, but they have their limitations. So we'll often need to group together chemicals into functional groups and then assign a proxy or a best match for these. For chemicals which are of incredible significance to each LCA, then you may want to look into one-to-one modeling. So in which case you need a chemical or an LCA specialist to then spend a large amount of time, maybe days or weeks, to assess the reaction pathways and to map these individually using technical LCA software. And to do this requires decision making. So sustainability managers, supply chain managers need to decide what chemicals in their portfolio need modeling. But you have to do that blind because you do not know at that stage what the impact of your chemicals are. So by only being able to do a select number of chemicals in your portfolio, you may be putting that amount of workload into the wrong decisions. And this traditional approach does work if you want to do an individual EPD for one chemical or one product, but it basically falls apart when we're looking at trying to do full portfolios at scale. So if we take this approach at scale, and we have a large number of chemicals used across a portfolio, which have been mapped to average or proxies within an LCI database, then at the portfolio level, this propagates into overall hotspots and analysis, which are based on average data. And therefore, it becomes incredibly difficult to defend any decisions based on this data, because we know that the environmental, the cost, the risk is based on generic modeling of chemicals. And it is not truly reflecting the supply chain you are operating. And this is totally understandable because we know from regulatory pressures, from customer pressures, that sales teams need to be able to provide environmental data, risk data, compliance data to their customers. And therefore, trading accuracy for speed is a business necessity. And something we understand at Makersite as well. We are still trying to prioritize the most useful part of improving supply chain mapping. And what we're going to present here for ChemAI is a route to improve those mappings where there are data gaps in your chemical data. So the big question, what is ChemAI and how are we proposing to solve this problem? So ChemAI, at its most simple form, is a gap filling capability. So this is fully embedded within the Makersite platform, and it is used for when chemical data is missing. So at the point at which you decide there's no premium data set, there's no supplier information that can fill that gap, ChemAI can generate a synthesis model for that chemical. And this is a structured, reusable, editable data set that can be used alongside other premium lifecycle inventory data sets. And ultimately, it allows companies to perform LCAs and compliance checks even where primary data is not available. So we'll now look a little bit how this actually works. So in order to use ChemAI within the Makersite platform, you can use your data in exactly the same way as you would do anyway. So you upload a bill of materials and material master, a bill of processes with your product information in. And the Makersite platform already holds premium data sets such as eco-invent and carbon mines, and where made available, specific supplier data. And the priority is to map to supplier data or to premium existing data sets. However, where these gaps exist, which we know are numerous, ChemAI detects this gap and is triggered to generate a synthesis model for this chemical. So, provided this chemical has a clear official chemical name, which may be recognized in the PubChem databases, and ideally a CAS number, it then uses a preset number of prompts in a background large language model to determine what the most typical synthesis route is for this chemical. So it will identify a stoichiometric reaction, and for each of those reactants, it will then check if they can be mapped to existing data sets, such as eco-invent and carbon mines. If it cannot, it will run up to 3 iterations to then run ChemAI to determine how those reactants are also synthesized. At the end, it will produce a clear synthesis route for this chemical where all data is fully transparent and traceable and also editable. So any practitioner can go in, review what has been mapped by ChemAI, and the requirement of this tool is that it undergoes a human expert review. So when it is generated on the platform, it will require validation, and this can be done by Makersite, or it can be done by a customer who has the expertise to do so. A key thing here is that all ChemAI models are mapped ultimately to existing LCI inventory databases, either held by Makersite or public ones. And therefore, the models that come out of ChemAI are fully consistent with the wider LCA methodology. So there's no methodological conflict in the models we create. And you can consider ChemAI to be essentially a research assistant. So it's producing that first draft of how a chemical is most likely to be synthesized in industry. And because it's fully transparent and traceable, you can then go in and make edits to say, actually, our supplier isn't using that chemical, and they can swap it with something else, or actually we've swapped to renewable energy, so you can remove that generic electricity process and make it something that's specific to your product. So the output of this is that you can understand the composition of unknown chemicals, and you are avoiding the use of proxies. So again, we're getting a best match for industry. We're not trying to replace accurate supply information, but we're looking to provide clear chemical synthesis routes rather than mapping to something like organic chemical or another simple proxy, which could be significantly underestimating the impacts of your chemicals. And we know this to be the case that for specialty chemicals, particularly in the pharmaceutical sector, the impacts may be 10, 20, 100 times more than organic chemical, even though that's what we're falling back on to rely on in the absence of good chemical data. So I know it's difficult to understand it without seeing the platform. So I'll now run a quick demo to show what this looks like in practice. Sophie, let me know when you can see my screen. All good?
It's loading. Now we are there. Yep.
Now we're there. So what I've got on the first screen here is a very simple way of getting the chemicals into the Makersite platform. So this is a very simplified bill of materials for two chemicals that I know do not exist in EcoInvent or Carbon Mines or other data sets within Makersite. So we have benzyl salicylate and magnesium acetate. So their name, their amount, and a CAS number. So typically, if you were actually working with Makersite, you'd be uploading a list of many hundreds or thousands of chemicals at once. So within Makersite, you come to a dashboard where we can see various apps, and you'd search your whole portfolio of products. But here, we look at importing a bill of materials, and I would simply drop in that Excel spreadsheet into here. Typically, with our big enterprise customers, we have a direct link to their enterprise software systems, so they wouldn't be doing a manual upload. So then, once that's uploaded, it takes us through to a mapper screen. And these two boxes here is where the match would be run. I'd already pre-run it, and it takes a couple of minutes per chemical to run a match. And here in the status bar, we can see it needs validation, which suggests it's from ChemAI rather than mapped directly to a premium data set. So first of all, we'll take magnesium acetate and look what's been generated by ChemAI. So I'll zoom in slightly. So what it's done is created a new product group for magnesium acetate and also a number of manufacturing processes. So as I explained, ChemAI looks for the most typical manufacturing route for the chemical in question, but it will also generate a number of different manufacturing routes based on what it sees in the market. So the one it's chosen is direct neutralization of magnesium oxide with acetic acid, but we can also see options for using magnesium hydroxide or magnesium carbonate as the main reactants in this chemical reaction. And you can readily choose the one that most suits your supply chain, or otherwise you rely on the one that's most typical for the market. So now we'll look into the app so we can look at what the climate change impact is for this chemical. So we can see what it's been mapped to. Let me just zoom in. So we have magnesium acetate as an output, and you can see it's being tagged orange as needing validation. And before this can be used in a data set and be used alongside other lifecycle inventory data set entries, it would need to be validated by a user. But we can look at that and we can see that it is mapped to acetic acid, and that's mapped to an eco-invent process. And equally, magnesium oxide has mapped to a suitable eco-invent process. We also have electricity and heat added, and these are based on our own research into what typical energy usage is for chemicals of different types in different markets. So we can look at typical inorganic chemicals and apply an amount of electricity or heat to each of those. We wouldn't use a large language model to estimate this because we've seen this to be unreliable at this stage. And then we could do a quick look at the impact. So 3.8 kilograms of CO2 per kilogram, it would seem reasonable. So then we can go through and we can validate that, and it will be available then as a raw material to use within your portfolio. We'll take a quick look at benzoyl salicylate as well. We can see there's a couple of different esterification routes that this can take. We'll just let that load. And we can also see within the product information, which I didn't show for the last one, is that you get a bit of information as to what's been chosen as a synthesis route. So it said a yield, 92%. We can see the stoichiometric equation for its reaction and an estimate as to what market share of benzoyl salicylate is produced by this route, and a small bit of narrative to say why this has been chosen as the most typical route. Again, in the climate change, we can see, again, it's mapped to existing data sets for salicylic acid and benzoyl alcohol. And again, you can do a review of the carbon impact and see that it is suitable. And then you could go through again and validate that to say that can be then used as our raw material in our data set. So that's a very quick tour of how it works within the Makersite app. I will then go back to the presentation. So have you seen the presentation in full screen?
Not yet, no.
I don't know how I return that to full screen.
No.
There we go. Thank you very much. Yeah, so I myself, I'm relatively new to Makersite, and I would have had questions around this when I joined, and I did indeed. So these are some key guardrails that we have in place for ChemAI. So first and foremost, it's not a replacement for supplier provided chemical data. If you have the exact data for which your chemicals are produced, you should be using that to model your chemical. And we would encourage all of our customers to request this data from their suppliers. ChemAI provides an educated first draft and not a final answer. So as I said, you can consider it as a research assistant to say, this is how a chemical is most likely to be produced. But as we know with AI, it can come up with some spurious answers. So you want to make sure we have a human expert in place to say, yes, the outputs from this process are realistic and they are correctly mapped. So we're not using any of these results blind. We're using it as a first draft to save a lot of desk research time on researching these chemicals. Currently, our focus is on traditional synthesis, so we haven't assessed physical blending, mining, or any biotechnology-based chemicals. And then a final point before we go to Q&A is that we are currently considering just the stoichiometrical calculations used for generating these chemicals. So we're not considering how solvents and catalysts will be used in the production of the chemicals. We know that particularly in pharmaceuticals, these may form a large impact, a large proportion of the impact of the chemicals. But the way our platform is set up is that all of these processes are fully editable and transparent. So by working with the correct experts, we can then add in solvents and catalysts in a way that suits the particular use case, because we know that using AI for these, we cannot reflect the nuances and the details of that specific supply chain for those chemicals. So that is a whistle-stop tour of ChemAI. I'm sure many will have many questions, and we are keen to open the floor up to questions now. And I think, Sophie, you will be moderating now what questions we'll be answering.
Exactly. So just a quick reminder, please post your questions in the chat and we'll go through them and try to answer as many as possible in the time that we have left. Obviously, if there are any questions open that we couldn't answer within the time, then we will come back to you and answer those later. Yeah. Good. Then let's see. So, yeah, okay. The one, how does ChemAI estimate the use of auxiliary materials such as catalyst or solvent use and waste generated for chemical reaction? Where does the background research come from? Patent literature, research papers. Peter, do you want to take that one?
Yep, happy to take that. So as we said on those last point, we aren't currently considering catalyst and solvent use, so that would have to be an addition added on a case-by-case basis. We are considering waste generated, so any excess materials, any allocation is included. So where multiple reagents are needed, you'll have multiple outputs. So either allocation or that can be considered a waste. In terms of the background research, we are primarily, Sophie, correct me if I'm wrong, using PubChem. So we're looking at generic synthesis routes and also beyond the large language model in terms of whether those synthesis routes are reflected in industry. So it will probably identify a number of synthesis routes from a source like PubChem, and then it will determine if they are used widely in industry.
Yeah, and it will choose the one as default that is basically the one where the biggest market for that chemical is. So that is basically the logic that is behind at the moment. I hope that answers this question. Next question is, will LCA results partly generated with AI be ready to submit to third-party verifier to obtain EPD? So that is basically based on A, the program operator, and B, the PCR that you're operating within. It is to be, as we said, it is to be, that is the wrong wording. It is a proxy data set to be as clear as possible, right? It is a very informed proxy data set, and I would, based on what we have seen so far, I would say it's as good as the research from an LCA specialist. And after, as an LCA specialist looked at it, it's definitely a very good data set. Still, it is supposed to be a proxy data set. Peter, anything you want to add there?
Yeah, I would add. Yeah, I agree with you there. The way it's presented is it's fully transparent and fully mapped. Is the same way as you'd want to present an LCA for external review. So a reviewer could see what's been mapped, how it's been mapped, and it's at their discretion to determine whether that is suitable for the mapping we've chosen. There's no difference compared to whether a researcher or AI has mapped it, because we're fully transparent in terms of what's been included in the inventory. And we include that verification step to say that what's been mapped is sensible.
Yeah.
There's no black box element to it.
No. In the end, it comes back to the PCR and the verifier, because basically it is transparent, so it is according any rule. But if it goes through, that's a discussion that is, yeah, to be done with each program operator. Good. Then we have another question. How transparent is the result of your data cleansing documented? Do you reflect the formal quality of ingredients? For example, original data, normalized, AI transform, matched guessed based on third-party data. I'm not 100% sure if I understand the question correct, so I'll take my my route to it, and Peter, you might want to add. So as you have seen, it is very transparent if it is an AI generated data set or not, because it is always to be validated before it can be used, and it always will have that flag, right? It is very transparent in the sense of what the input and the inventory of the data set is. And it also comes with that explanation of what basically things as like what's the route, what is the stoichiometric formula in the background and stuff like that. So it has documentation. I'm not 100% sure, Peter, maybe you have another take on that question?
Yeah, perhaps it may also refer to the sort of the step before ChemAI, which Makersite might do. So if we get a list of materials from a customer and they aren't incomplete, as in there's missing CAS numbers or some of the names aren't quite right, we may use then an AI tool to say, please generate the CAS number and the associated pubchem name for this chemical. And then we would potentially go back to the customer and say, can you review this list to say it reflects the chemicals in your material master? So this is more of a pre-step perhaps to the ChemAI process. Because if you upload a name of a chemical which is a brand name or a non, like IUPAC name, then you're not going to get a good ChemAI match. So this is sort of a preloading step to ChemAI perhaps.
Thank you for that. And then we have another question. Does the ChemAI map the material and energy datasets to only equipment, or can we have an option to ask this to be mapped to different databases such as carbon mine, sphere, etc.? So yes, Makersite, you can go in any dataset. You should actually go into every dataset and check the mapping, and it can be mapped to equipment, but it also can be mapped to any other database that is available within Makersite, or also supplier datasets if there are any within your platform. Because one of the databases named is also Sphere. That is one of the databases that is not included within Makersite. Peter, anything to add from your end?
Yes, if you are in, if you had a Makersite license and you had your own platform, then you can also create private datasets yourself. And these could then also be used to match if you had, say, as Sophie says, supplier data, or you generate a set of impacts through ChemAI. They could then again be used as raw materials for a second running of ChemAI if they were used in other products.
Yeah. Then we have another one. Is a DQI assessment done and provided for the chemical data set created by ChemAI? So, Peter, you want to answer to that one? Should I?
Yeah, I think you can go for that one.
Okay, so the DQI assessment is available for any of our products any of your products that is uploaded to the Makersite is basically will have a DQI assessment, but actually I have to check for the dataset itself if this is also displayed there. I think yes, but I owe you that answer and will let you know as soon as I am absolutely sure. Yeah. Good. So it's 5:30, and I think we are at the end of our webinar. As said, we will definitely send you the recording and the presentation, and we'll also come back to you if there were any questions that haven't been answered so far. Thank you very much for joining. Thank you for being here, and see you next time.
Thanks, everyone. Thanks, Sophie.
Thank you, Peter. Goodbye.
Bye.